Um, okay, it's on. Hello, everybody. My name is Gautam Borgohain. Are the slides up? Oh, yeah. Okay. Hello, everybody. My name is Gautam Borgohain. I'm a data scientist at PropertyGuru. And in this session, I'm going to talk about how we use machine learning at PropertyGuru. Before I start, let me start with a brief overview on PropertyGuru itself. We are an online property marketplace, and we connect property seekers to property agents. We started a while back in 2007 in Singapore, and now we are in 5 different countries, including Malaysia, Indonesia, Vietnam, and Thailand. We are actually the leading PropTech company in Southeast Asia. We have over 2.4 million property listings, and we have a monthly user base of over 23 million users. As a company, our vision is to be the trusted advisor for property seekers. And in order to achieve that vision, we know that we need to help people make confident property decisions through relevant content, actionable insights, and world-class service. Now, as you can see from our mission statement itself, having relevant content and actionable insights, machine learning plays an important role in achieving our vision. The data science team in PropertyGuru itself there are 5 of us who are data science and machine learning engineers. We all have different backgrounds from some engineering and some bioinformatics and statistics. And we rely on tools like driverless AI to find the best possible models for the different use cases that we work on. In today's session, I'm going to talk about some of the areas where you're using machine learning to build products that help people make confident property decisions. More specifically, I'm going to talk about 2 different areas. First is how we enable better discovery of listings, and second, how we maintain the quality of those listings. First up, let's look at PropertyGuru Lens, which is how we enable the discovery process for users. Now, normally, property seekers use filters on our website and search for the listings and shortlist and so on. But if you were looking for all available units in a building that you just saw and you liked, and you want to go online and search for that, you'll have to use your detective skills. You'll have to know where you saw that building, what color it was, etc. So we recently launched PropertyGuru Lens, which is the first app of its kind in Southeast Asia that uses augmented reality to allow property seekers to discover properties by just pointing their phones at them. The app then presents a list of all the available units in that building for rent and sale. It is like having your own personal property expert on the device itself. We are able to do this by running a couple of models that take input from the camera and geolocation data, and we do some field of view adjustments to make sure we are accurately identifying the building that you're looking at. All the processing that we do happens on the device itself, so it's private, and it has been optimized so that it uses minimal battery power. Actually, the model itself is just 2 megabytes in size, and the latency for scoring over a catalog of 8,000 condos is just 6 milliseconds. Another thing that we use to help in the discovery process for users is personalized recommendations. Now, recommendations are generally used almost everywhere now, but while building the recommendation engine for PropertyGuru, we had a couple of considerations to keep in mind, which were not available, which were not usable in the off-the-shelf solutions that were available. Firstly, listings expire. That is, once an agent completes a deal, he takes the listing off our site. And even if the unit were to come back on the market, it would come on as a different listing. Now, generally, recommendation engines rely on the signal of similar items occurring in different users' activities. And because we have this time frame limitation, that signal for us is very sparse. So we had to change our algorithm to modify around that and add these cold listings which do not get as much user activity. Secondly, we know from previous research, user research, that property seekers have different preferences in different stages of their journey to finding their home. So initial phase is like the discovery phase, where they are expecting more variety in their recommendations, and they're looking for multiple different properties and even locations. While further down the line, after a certain amount of time, after a couple of weeks, they are looking at more granular recommendations, where they are basically looking for the best deal. And taking all these factors into account, our custom recommendation engine is now able to serve our catalog of over 2 million listings in all the regions that we have to our user base of 20 billion. And we personalize it real time with our API being able to operate at just 95 milliseconds of latency. Also, to help in the discovery process, we allow the agents who post these listings of the units valuable insights on their listings performance, so that they know how their listings are performing. And we also give them tools that allow them to manage and promote selectively some of these high quality listings. For example, here we are asking this agent to promote this particular listing because we think that that's going to get him more leads. Now, how do we know this? We know this because in the background, we are running a listing. We have modeled this listing's performance based on the current demand and supply and its competitions that are there for similar listings. So we have calculated the propensity for the listing's performance to increase. That means to get more leads if it were promoted in a certain period of time. So insights like this not only help agents get more value out of our platform, but also also helps match the right listings to the right users. Now let's look at how we maintain the quality of the listings. So we are doing all this stuff of aiding the discovery process, maintaining the quality of the things that our users, our property seekers are seeing is also very important. Now, since we are online, agents are basically uploading different content. They are adding images to listings and giving a lot of descriptions. And property seekers, when they are on the site, they need them to be high quality. That is, they have to be relevant and informative. You're basically looking for a virtual tour experience of a property when you're browsing online. Now, up until April of 2019, we allowed images that did not meet all our guidelines to be uploaded regardless. So our site used to look something like this, with a lot of overlays, distractive banners and neon-colored phone numbers and face overlays. So as a property seeker, that creates a very distracting experience, because you're not able to see what that property is. You're not able to see how the room actually looks, but you're being distracted by all these different noises. So we started monitoring the images that are uploaded, and given the volume of images that get uploaded in our different regions, we use multiple machine learning models to do various checks before the listings goes live, basically. So our image moderation stack is basically 4 different tasks. First is aspect detection, where we are identifying banners and overlays in text, like the banners that are here on the top and on the bottom. Second, we do object detection to localize some of these objects, and plus some other objects specific to properties, like sofas, etc. We do this to know where exactly and how much of an area is being covered by these faces and all these overlays on the images. Thirdly, we do scene detection, whether the image is of an indoor kitchen or an outdoor dining area. We do this so that we can understand, we know the coverage of the unit by the images. That is, do we have images of all the bedrooms that are mentioned in the listing or not? Lastly, we also evaluate the quality of the images that are uploaded. So we use a model that generates an aesthetic score for the image that has been uploaded, and we use that along with some other image quality features like sharpness, the brightness, and the exposure levels of the image to recommend the best cover image for a listing. That's image moderation. Text is uploaded on our site as descriptions, and basically agents add more context in a description, like how old the property is and any additional preferences by the user, whether or not it's a co-sharing apartment or not. Moderating these descriptions is also very important. Now, we do some general topic analysis on these descriptions, like text analysis on these descriptions, like getting the topic, whether or not it's relevant to property or not. And we do some blacklisting of keywords based on our prior experience and things that we don't want to be mentioned. But bias detection is something that we do that is quite important, actually. But what is it? Bias detection is basically detecting phrases in text that hint or explicitly state preference based on race. For example, if a listing has in a description that inquiries from only a particular race would be considered, that is something that we do not want on our platform. So we build a model that detects these inherent and explicitly stated biases in the descriptions. We started off with using bidirectional LSTM model using word-to-vec embeddings, but soon we realized that a lot of the words that were used in these contexts in this when specifying these preferences did not exist in the word-to-vec vocabulary and in general English vocabulary. For example, words like Chindian, which refers to a person of mixed Chinese and Indian descent. So this led us to experimenting with bigger models like BERT, and we got the performance that we need, but they're really big models with like 110 million parameters that were very hard to be deployed. So we use knowledge distillation to train a model that is 10 times smaller in size while getting the same inference. And so right now we do batch moderation of these listings and remove all the listings which violate these particular these guidelines. Okay. Lastly, I want to end by talking a bit on model deployment. As you can imagine, deploying these models that we just talked about in a scalable and performant manner is very important. And due to the small size of the team and because we do the whole process end-to-end, we prefer serverless deployment, whether the models are built on PyTorch, like simply on PyTorch, or via driverless AI. Now, in the example that I've shown here, this is one deployment of one of the tasks in the image moderation stack that I talked about earlier, where we are using models for detecting face overlays, text overlays, and other NSFW detection of the images. We asynchronously call these different Lambda functions which are serving these different models, and then we collate their results if they are from the same task or a different task, and process them for downstream consumption. Now, making deployments like this serverless, we saw especially for our image moderation use case, we could process up more than 10,000 images a second, which is much more capability than we actually require for our live API. And we have noticed that having this process of deploying to serverless in AWS Lambda means that we always end up having that step of optimizing our models further. For example, using knowledge distillation or quantization to reduce our model size to adhere to Lambda restriction or serverless restrictions. So not only the models become smaller, but they also become more efficient and faster. and they're more cost effective. In fact, we found that hosting our image moderation stack on Lambda made us reduce cost by almost 97% compared to a previous way of hosting them on GPU instances. So we really think that having this our current state of using the best tools which help us iterate faster, and using tools like serverless and driverless AI to deploy and maintain these models faster has been really helpful for us. And that's all from me, and thank you so much for listening. If you want to reach out, feel free to reach out on my email. Thank you.